Imagine the asteroid misses. No blinding flash over the Yucatan, no global firestorm, no long winter. The Cretaceous simply keeps going into tomorrow. What kind of Earth grows from that single change? And the question everyone wants answered first, in a world that never cleared room for mammals to explode into every niche, would humans exist? Begin at the shoreline of a warm, high-sea world. It's 66 million years ago, but we're staying. The continents are still drifting, the Atlantic is widening, India is racing toward Asia. Tropical forests crown much of the land. Grasses exist, quietly spreading from margins and floodplains, not yet the endless seas of wheat we know. The air is thick with insects, the sky is not empty, pterosaurs still cruise the thermals, birds, already dinosaurs, share the air. On the ground, the kings are diverse, not just giant. Herds of hadrosaurs grind plants with battery-like jaws. Ceratopsids wield horns that mean business. Armor-backed ankylosaurs rumble like living tanks. Small, fast, big-brained troodontids stalk the dusk. Dromaeosaurs, raptors, hunt in bursts of speed and coordination that would humble wolves. Tyrannosaurids are apexes where they live, but they're not the only headline. Giant crocodilians own the rivers. In the oceans, mosasaurs and plesiosaurs carve migratory lanes through ammonite-rich seas. Now lift the frame and let time flow forward without the reset button of a mass extinction. Climate still shifts. Volcanoes still breathe. Sea levels rise and fall. But instead of a sudden wipeout, evolution works like a jazz set that never stops. Motifs morph, new riffs layer on top of old ones. Lineages that would have died at the KPG boundary survive and keep branching. Birds still radiate, but they do it in constant competition with pterosaurs that never gave up the sky. Small mammals still exist, but the pressure above them never lets up. Without a sudden vacancy sign across the planet, the great mammal takeover doesn't happen on schedule. What does that mean for primates? They already exist in the late Cretaceous, tiny tree-dwelling insectivores with eyes tuned for night. In our world, after the asteroid, their descendants climb down, grow larger, learn to eat fruit and leaves by day, and move into the spaces giant reptiles once held. In the world we're imagining, those spaces were never empty. Primates still diversify. Nature rarely just stops, but the ceiling is lower. Raptors love the taste of curiosity. Big herbivores trample experiments that try to learn the ground. The smartest primates become even more nocturnal, even more arboreal, even more cautious. Intelligence grows where it buys survival, but the ladder to us misses rungs. So let's split the thought experiment into two paths. Path 1, the most likely one. No humans. Dinosaurs dominate big animal niches on land and in the air. Marine reptiles and sharks share the seas with giant fish. Mammals are clever specialists, burrowers, gliders, nocturnal omnivores, some mid-sized, a few bold species reaching the size of foxes or even deer. But the very large herbivore slots, those that in our world went to rhinos, elephants, bison, belong to hadrosaur and ceratopsian descendants that learned to graze as grasses conquered floodplains and then plains. Ankylosaur lines produce slow, low lawnmowers with incredible gut chemistry. Carnivoran niches, wolves, big cats, bears, belong to tyrannosauroid and abelisaurid branches that slim down for endurance or rebuild for sprint and ambush in open grassland. Imagine a pack-hunting, mid-sized tyrannosaur descendant with long legs and a high aerobic engine, more cheetah than bulldozer, working the edges of herds. Imagine raptor descendants that trade some killing claw for better grasping hands, more social cues, longer juvenile periods to learn. Birds, the dinosaurs that really made it, get squeezed from above by pterosaurs that never left, and from below by small theropods that never died. Some bird lineages go hyper-specialist, filter feeders on inland seas, ground-nesting sprinters of the savannah, arboreal tool users with parrot-like problem-solving cranked to 11. The greatest flyers by weight are still pterosaurs widening their wingspans on island chains. Seabird giants exist but learn to share. In this path, intelligence blooms in multiple places but never locks into human. Raptor-like theropods with high encephalization, think troodontid descendants, converge on corvid-level problem-solving. They cache food, use stones, pass knowledge to their young. Pterosaur fishers turn into ocean-clever strategists like sea otters with wings. Some mammals are geniuses inside trees, living lives so secretive we would have missed them until the 20th century. But fire never belongs to hands, and language never recruits a throat and tongue to shape syntax into cultures that outlast lifetimes. The planet is loud with voices and quiet of cities. Path 2, narrower and stranger. Humans, or something frighteningly close, appear anyway. Evolution is a gambler with infinite patience. Even under dinosaur dominance, chance and geography make laboratories. Africa fractures and fuses. Mountain ranges rise and rain shadows make corridors. Islands bloom and isolate. In one of those laboratories, a primate line threads its way through the lattice of risk. Perhaps it takes refuge in mangrove swamps and learns to wade and throw. Perhaps it steals the night with fire stolen from lightning. Perhaps the big predators in that region are busy with richer prey, or an epidemic prunes their numbers at the wrong moment. Given a few million years of this narrow grace, an upright ape could still step onto a savanna rim and look out across a world that does not want it. What then? Civilization under dinosaur pressure would not look like ours. Agriculture assumes fences that stop cows and weather that spares grain. Our fences would need to stop half-ton beaks that think in teams. Our granaries would need to outwit long-memory raiders. Imagine villages inside moated enclosures with inward-leaning palisades topped by overhangs and mirrored plates. Raptors hate vertical, slippery, unstable surfaces. Dogs may not exist. Canids might never break out beyond fox-like niches if hyena equivalents are theropods. Our first domestic partners might be bold, omnivorous mammals, the raccoon analogues of this world, or even small social theropods whose temperament allows taming. Chickens are dinosaurs we already domesticated in our world. In this one, their cousins might be larger, faster, sharper. A line of small omnivorous oviraptorosaurs with tolerance for human presence could become our feathered pigs. The sky complicates everything. Pterosaurs make air travel hazardous until technology gains teeth. Early balloons get punctured by curious wings. Even after powered flight, routes avoid major rookeries. But the same flyers carry cameras and map coastlines for us. If we learn to partner with a few species, we might strap sensor harnesses and let them do science for snacks. Falconry, but with pterosaurs in thermal columns and a vocabulary of clicks and color flags. Predation shapes cities. Streets are roofed. Public squares are netted except on festival days. Trash is locked. There's a reason we invented myths about dragons. In this timeline, we can point at them. Night markets hum with deterrent torches because fire still speaks at a deep level to every archosaur nervous system. This is the one thing that bites what bites us. Hunters carry polearms designed not for boars, but for slicing the tendon at the back of a taloned foot. Farmers grow thorn hedges thick with resin that gums up feathers. Children learn to freeze when a shadow passes. Technology runs through different bottlenecks. Step 1 is controlling fire. Step 2 is building stores that aren't raided. Step 3 is metals. Metallurgy might actually arrive earlier in some places because the need for better spearheads is urgent. Crossbows appear early too, reach before speed beats a sprinting predator. Pastoralism looks alien. No cattle herds on open ranges. Grazing happens in rotating armored paddocks. We might build terraced farms under lattice roofs that plants love and raptors hate. And when we finally reach electricity and telegraphs and radios, we celebrate by stringing lines not just along railroads, but like spider webs over towns. Every wire is both communication and sky fence. Would dinosaurs learn us back? Absolutely. A few lineages become urban opportunists, just like pigeons and rats with feathers and claws. You will see a juvenile pack practice flanking maneuvers around a market stall while the adults distract. You will meet a ground bird with the face of a small tyrannosaur that waits at intersections for lights to change because the pattern pays off. You will shake your head at footage of a clever troodontid using thrown stones to break security glass on a bakery. Then installing beak-proof panes becomes city code. We will declare war on them. They will teach us limits. Eventually we will cut deals without knowing we're doing it. Schedule trash pickup at dawn so the pack is full by midday and less motivated to test school fences. If this sounds exhausting, remember the flip side. A planet with more wild majesty than ours kept. Whale song in the air and thunder lizard silhouettes on the ridge at dusk. Forest canopies alive with color and sound. Rivers with crocodilians larger than trucks that we respect like weather. We would build festivals around migration calendars. Our literature would have a shelf called Raptor Escapes, the way we have mountaineering epics. Every frontier town would have a brass plaque listing the names of those lost to the wild, and we would still go, because humans do. Back up and ask the evolutionary question that decides the whole thought experiment. If you remove a mass extinction, do you also remove the path that leads to us? The sobering answer is almost certainly yes. Not because we are impossible, but because we were improbable even in the world that did happen. The KPG extinction erased the incumbents. Mammals expanded not because they were destined, but because empty seats were suddenly available on the bus of life. Without that vacancy, the bus stays full. Intelligence with hands might still evolve, but its odds drop. Its timetable shifts. The library it builds is different. And yet evolution loves parallel solutions. Eyes evolved many times. Flight evolved many times. Echolocation evolved many times. Complex social learning evolved many times. Even in a dinosaur-dominated world, some lineage was going to make a bet on bigger brains, longer childhoods, deeper cooperation. Maybe that lineage is a dinosaur. Paleontologists have argued over the dinosauroid, a speculative descendant of a big-brained troodontid. It's not a prediction, it's a thought tool. But it reminds us, big brains are expensive but powerful, and evolution pays the bill when the payoff is survival and reproduction. If a raptor descendant discovered fire control on the savanna margin, our role in this video would be reversed. We'd be the nocturnal tree thing telling stories about the clever ground lizards who thieved the lightning. How would the rest of Earth change without that extinction? Plants go on their own march. Flowering plants already ruled by the late Cretaceous. They keep co-evolving with pollinators, bees, beetles, butterflies, birds, with no reset. The grasslands we know still appear as climates dry and cool in places, but their first giant grazers are hadrosaurs, not antelopes. Soil builds under different footfalls. Seed dispersal patterns follow different highways. Termites and dung beetles specialize on dinosaur waste. River cycles accelerate with bigger herds. Fire regimes shift with new grasses and shed feathers. Lightning storms paint mosaics rather than continents. The oceans keep their monsters longer. Mosasaurs don't vanish, they subdivide the seas. Some shrink and blitz like dolphins, others widen heads and crush ammonites that never left. Sharks still win in the long run. Cartilage is cheaper than bone, but the race takes longer. Their peak diversity arrives on a new schedule. Coral reefs face different pressures. Grazing fish evolve sharp beaks to scrape algal films that ride on the wake of giant reptile nutrients. It's a world where beach warning signs include icons you've never seen. And the climate? Without the dust and smoke of a planet-wide impact, you skip the immediate winter, but you don't skip plate tectonics, volcanoes, orbital cycles. The late Cretaceous was a greenhouse with polar forests and crocodiles at high latitudes. Over millions of years, CO2 drifts down as mountain ranges weather and lock carbon in rock. Ice appears where it always would when continents drift into the right places. Dinosaurs, warm-blooded to various degrees, track the isotherms and evolve insulation in more lines. Feathered coats spread beyond the small and the flighted. Arctic theropods grow winter down that makes a goose jealous. Now, for the storytelling reward, take the no humans path and call it likely. Take the humans anyway path and call it thrilling. Then find the overlap. Less likely, but not empty. If you need to explain this at dinner, give them 3 sentences. 1. Birds are dinosaurs. So in a sense, the dinosaurs never went extinct world is already partly real. 2. Without the asteroid, non-avian dinosaurs would probably still rule big animal niches, and mammals would remain smaller, later, and rarer in the large body slots. 3. A human-level intelligence could still evolve, but whether it's us or feathered or something we can't picture depends on millions of coin flips we never get to see. There's a moral hiding here that isn't about monsters at all. Contingency runs the show. We are not the inevitable crown of anything. We are the result of a shattered day 66 million years ago, and everything that luck and selection did with the aftermath. The alternate Earth where dinosaurs kept going isn't a paradise or a nightmare. It's a mirror that shows how razor-thin our path was. It says, be careful with the extinctions you cause. They rewrite the future more than you can understand. It says, a world can be richer, stranger, and perfectly complete without you in it. And it says, if you do get to exist, make it count. If you could visit that world for a week, you'd come home changed. You'd dream in feather shadows and wake up missing a thunder you never felt. You'd bring back a notebook full of field sketches, theropod tracks at the edge of a city, a child tossing fruit to a patient, beady eye that knows the schedule, a flight of pterosaurs crossing a winter sun like a living constellation. You'd tell people you finally understood what the word alive can hold, and they'd nod politely until a flock of pigeons swirled and you flinched, not because you were afraid, but because for a second you could see, in the angle of a wing and a turn of a head, the world we almost had. Would humans exist? Probably not. Could intelligence flower anyway? Almost certainly. Would the planet be less interesting without us? Not for a second. But since we are here, the best thing we can do is learn the lesson of the asteroid that didn't miss. Life fills every space it's allowed. Let's be the kind of species that makes room.